Good evening online. Yes. See, today's class is a very important class. Yes, come in. Any doubts in last class? क्या? I did not get. Repeat the question. Heat budget. रट्टे वाली काम है. ठीक है. Yes. It is factual. And definitely it is factual. But what you need to do is you need to use some logics there. For example, UPSC can enter into asking the total amount of heat that is absorbed in the atmosphere is primarily due to shortwave radiations or outgoing terrestrial radiations. Outgoing terrestrial radiations. Shortwave mein to 14 is the one which is getting absorbed. So here what you need to do is, this is how the questions can be asked. There's potential of this kind of questions that can be asked. Right? So incoming, so thoda factual content hai, that factual content you need to manage well. Deflection of? अभी आज समझा दूंगा. Convectional currents are nothing but it's a heat that is being transferred to, when a particular body is having heat, that continuously heat is being transferred to the various layers of the atmosphere. That is called convection. Okay? Yes? Convectional current, abhi I did not teach you. Wait for some time. Convectional currents are primarily, they are there in the geomorphology. Abhi tak maine to wahan tak pahuncha hi nahi. I told you, consider it as a fact also yesterday. Right? So, Coriolis force today I'll explain. Okay? I'll explain that. All of these questions, high pressure, low pressure concepts. And now we'll start today with the wind system of the earth. Okay? Which is otherwise also called atmospheric circulation. Okay? This is the concept. This is the topic. On this topic today we will be learning about what is low pressure, what is high pressure, how the winds move from high pressure to low pressure, and while the winds that are moving, what are the forces that impacts this particular wind. Now why sometimes the speed of the wind is high? Now why sometimes the speed of the wind is low? Why the wind create dust? Why the wind create rains? All of this has some kind of reasons behind them, and that reasons we will be trying to understand in this wind system of the earth, atmospheric circulation. Now this is studied at various layers. Okay? It is studied as primary circulation, it is studied as secondary circulation or tertiary circulation. Okay? So, on one side, you have first one, the winds that are present on the surface of the earth and on the upper atmosphere can broadly be classified into primary circulation, secondary circulation, and tertiary circulation. Now, what do you mean by primary circulation? Primary circulations are nothing but easterlies, westerlies, those winds which are present on the earth all throughout the year. Okay? Broadly, primary circulation includes planetary winds, such as easterlies or westerlies. Right? Now, what does secondary circulation include? Secondary circulations include Now what does terrestrial circulation include? It includes local winds. Now what are these local winds? Such as sea breeze or land breeze, Lu, Kal Baisakhi, like that. You have endless local winds. Now each of these, Kal Baisakhi in the nor'westers, mango showers, okay, blossom showers. These are pre-monsoon showers which are also called as local winds. Right? In simple, these are your local winds. Sea breeze ho gaya, land breeze ho gaya, Lu, Chinook, Fohn, Fohn. So like that, you have endless local winds, blizzards, right? So today we'll try to understand from the basics, that is primary circulation. And remember one more thing. Remember this very, very clearly. If primary circulation fail at a particular place, secondary circulations comes into picture. If secondary circulations also fail at that particular place, tertiary circulation comes into picture. Okay? Primary circulations are present all throughout the year, and in that particular place, if suppose primary circulations failed, they can fail in maybe 10 kilometers area, 20 kilometers area, 30, 40, 50, 60 kilometers area. Now, whenever that fails, secondary circulations comes into picture, like tropical cyclone, temperate cyclone. So, there is a cyclone which is present on India. Are you aware, if you are following the current affairs? What is the name of the cyclone? Yes? Say it loud. Okay. See, this is the real-time image of the Earth when it is looked from the Himawari satellite 8. Himawari is a satellite which is a Japanese satellite. Can you see this cloud cover? This primarily, this cloud cover is because of the cyclone. Now, if you identify a cyclone here, just a minute. Look at this Bangladesh. Can you see the winds? The winds are coming. Now, I'll point out the speed of these winds. Look, try to see. "41 kilometers per hour." Right? Look here. The speed of the winds is 54 kilometers per hour. Right? So, there is a cyclone. This cyclone here, they are secondary circulations. Okay? I am telling you, only when primary circulations fail, secondary circulations comes into picture. Always remember that cyclone is a low pressure system. Okay? Extremely low pressure system which is present on the ocean. That is called tropical cyclone. That we'll learn in little more detail when I go into the secondary circulations. But here you need to know, currently aap news articles follow karna, what is happening in the cyclone realms, okay? And as well as disaster management, how is it taking place? This is a real-time example with case studies you can look into. It can have the potential of super cyclone also, right? So this is a pictographic representation, but this here, if you look into, literally this is the real-time image of the Earth. Now, in India, today is the time where on one side there is monsoon, okay? Or else on one side there is a cyclone. On the other side, much of India is experiencing heat waves. This is a paradox. एक तरफ heat waves भी है, and the other side it is also having the tropical cyclones. So because of that, extreme natures of climate are there, disaster management, there's a 9 days of series of heat waves are given alert for this Chandigarh, Uttarakhand, Delhi, these areas. Now eastern coastal areas, they are alerted with cyclone. Now look at the length of this cyclone, look at this cloud cover, very, very thick cloud cover, right? So we'll learn about all of these things. Now first I'll be going towards primary circulations. In order to learn the primary circulations, you need to understand the concept of, number one, pressure system. See, this pressure system, firstly, you need to understand what is low pressure and what is high pressure. Yesterday I told you wherever you have low pressure, the temperatures will be high, and at high pressures, the temperatures will be low. Now, do you have any doubt in this? I said, if temperature is higher, then it is low pressure. When temperature is low, you will have high pressure, right? But we need to understand the concept of low pressure and high pressure in little more detail. The concept of high pressure and low pressure is studied at two different levels. One vertically and other one horizontally, right? How is vertical pressure different from horizontal pressure? Let's try to understand. Now for that, first you need to understand what is the term pressure means. What do you mean by atmospheric pressure? What do you mean by atmospheric pressure? How do you define it? How do you define atmospheric pressure? We are saying low pressure, we are saying high pressure. This temperature high, so I told you at that place you will have comparatively low pressures. But I asked, what do you mean by atmospheric pressure? The force exerted by air on our body. This is what Shaurya is saying. Is it right? Yes? So, see here, your atmospheric pressure in simple terms is what rightly said by Shaurya, the force exerted by air on our body. For that, if you see, imagine this is your earth. ठीक है? In other words, imagine that you are standing here, right? So, if I am calculating a column of air is, this is my column of air, right? And on this column of air, let's identify few places, few points. ठीक है? Let's consider this as point A, this as point B, this as point C, and this as point D. Right? Now, what is this person? A person named Shaurya. How much pressure is he exert? How much pressure is he being experienced? Is nothing but the total weight of air is being put onto Shaurya. Right? So, let's see. I have decided that I'll be shifting Shaurya to point C. ठीक है? Pressure कम हुआ या ज़्यादा हुआ? The pressure experienced by Shaurya at point C is more or less, is less. In simple terms, I can say that the pressure exerted or the weight experienced by a person at the ground level when you take a column of air, that is called as atmospheric pressure. Right? Now this atmospheric pressure is not same at every place. It can vary. Right? If the temperature is high in this column, and if I also take another column like this, imagine I have another person standing here, and this person is standing at the equator, and this person is at poles. Right? Who will be experiencing more weight of the air? Who will be experiencing more weight of the air? Ideally, I am talking about ideally. Do not use your brain. Only from the knowledge which I am giving you, you have to tell me. Who will be experiencing high pressure? Pole, why? Low temperature. But मैंने ये भी कहा था that the column of air is also matter. ठीक है? You know that at equator, at polar region, it is only till 8 kilometers. At equator, it is up to 18 kilometers. So technically, it is this person who has to experience more pressure, right? When you take a single column of air, I am not worried about what are the temperatures here. I am not talking about temperatures as of now, right? Atmospheric pressure is defined as the weight experienced by an individual at the sea level when an entire column of air is taken with respect to a column of air, right? So this is called as atmospheric pressure. Now see, this atmospheric pressure can also be measured like this. One, I'll take D dash point. I'll measure these two pressures comparatively. I'll take A dash point. I can compare these two. But as an individual or as a geographer, you're not supposed to compare this A dash with D dash. You should always compare the pressures at same height, right? In geography, pressure differences are always compared with the same height. Now here, you will learn about two things. One, pressure is measured in horizontal manner, horizontal pressure. And second one, vertical pressure. I hope you now got to understand what do you mean by vertical pressure. As you increase the height, is the vertical pressure increasing or decreasing? Decrease होता है, ठीक है? इतना confidently गलत बोलता है. Increase in height reduces pressure. When I am only talking about vertical pressure. This horizontal pressure concept I'll come little later. Okay, we'll first discuss about this vertical pressure. No. Navin's question is, sir, surface pe pressure and upper atmosphere mein pressure, do you have same logics? No. That logics are always different. I'll explain this. By the end of this class, you'll get complete clarity on this topic. So, see here, this is vertical pressure. Now in this vertical pressure, before I teach about this, you have to understand the concept of low pressure system and the concept of high pressure system. And how does this low pressure and high pressure systems work, right? So imagine that you have a surface area. Imagine this is a surface. Right? And here you have high temperature, and here you have low temperature. As per the logics which I have taught you earlier, when there is high temperature, what kind of pressure do you have? You have low pressure. Do you have any doubts in this? Why do whenever we have high temperature, why do we have low pressure? You're clear with this concept, right? So you have low pressure here, right? And here you have high pressure. Now let's try to understand how does this pressure system work vertically. What I'll do is I'll take a column of air. Okay, just imagine this is a column of air which is made up of low pressure, and this is a column of air which is made up of high pressure. Now how does the air behave in this? See, vertically, hamesha, whenever you are increasing your height, okay, always pressure decreases. For example, the sea level pressure is always, imagine this is a sea, the sea level pressure is always like this. Sea level pressure is 1013 millibars. Okay? When you rise your height to a height of 9 kilometers, the sea level pressure will be 260 millibars. Sorry, not the sea level, the Pressure at that point is 960 millibars. Sorry, 260 millibars, I'm sorry. 260 millibars at a height of 9 kilometers. Look at the variation in the atmospheric pressure. It is so high, right? So vertically, as you increase height, decrease in pressure, right? Now see here, wind always moves from high pressure to low pressure. Now where do you have high pressure? I'm only talking about, for some time, let's forget this column. Where do you have high pressure? Where do you have low pressure? Right? Wind always moves from? Where do you have high? You have low. Ideally, wind should always move upward in the atmosphere. But why is it not happening? And do you see the difference in the pressure? 1013 millibars to 260. ठीक है? 1013 to 260 is way, way higher. You know, cyclone, which comes with a speed of 100 kilometers per hour, what is the pressure difference, you know? Any idea? A wind that is coming with a pressure, a wind that is coming up within a speed of 120 kilometers per hour. What is the pressure difference that the wind is experiencing? मतलब इतना भी ज़्यादा नहीं, hardly 20 millibars का, 15 millibars का. ठीक है? If I show you here, look at this. The wind is 54 kilometers fast, it is traveling. And if I take this to another place, the wind here is 2 kilometers. Why is that within such a small gap the wind has to change its speed? Now, why the wind speed is so high here? If I take to this point, the wind speed will be more higher. See, within the cyclone, the pressure difference is hardly 15 millibars, 10 millibars. मतलब एक high pressure और low pressure की फर्क which is there in the sea, it is only 15-20. But imagine 1013 millibars at this level and 260 millibars, which is near about 600 odd millibars of variation is there. Now this 600 odd millibars of variation, it is literally you should be ripping off your body and moving up. Everything and anything which is there on the surface of the earth, be it this chair, be it this table, if this is the ideal conditions, all the material should go up with the wind. But it is not happening because if this is your earth, अर्थ के पास एक ब्यूटीफुल चीज है बाय द नेम ग्रेविटी. सो ग्रेविटी इज बैलेंसिंग द प्रेशर ग्रेडियंट फोर्स. ठीक है? द गैप बिटवीन हाई प्रेशर एंड लो प्रेशर इज कॉल्ड एज प्रेशर ग्रेडियंट. ठीक है? आई एम यूजिंग ए वर्ड प्रेशर ग्रेडियंट. Pressure gradient is equals to the gap between high pressure and low pressure. Now, what is the gap of 1013 minus 260? Gap in the sense subtract करना है. What is the gap of 1013 and 260? Yes? 750? 753 is the gap. Right? That means the pressure gradient, itna zyada gradient which is there, is it not being balanced by gravity? It is being balanced. That means the vertical pressure gradient, can I write like this? Is this statement right? Yes, this statement is right. The vertical pressure gradient is balanced by the gravity. Now coming back, Look at this particular place. Now this is literally sorry, a vertical pressure system. Now in this vertical pressure system, you need to know few characteristics also. Now what are these characteristics? Look here. One thing. If this is 0 and this is 3 kilometers, there is friction present here. Less friction. ठीक है? More friction and less friction, because this air is in contact with earth surface. That's why it has more friction, and this air is not having friction, so it moves in irregular manner. It will not listen to the general principles. Right? This is something which you need to know about the vertical pressure gradient. And literally in the lower reaches, for every few meters, there is a variation of pressure. There is large variation of pressure. Have you read the NCERTs? Yes. How many of you have read? उसमें ये लिखा होता है, for every 10 meters there will be a variation of 1 millibar. Is it written? See, in NCERT it is written as, for every 10 meters of height, the pressure difference is 1 millibar. That means if you are moving from 0 meters to 10 meters, there is a pressure variation of 1 millibar. Like that, in 1 kilometer, how much variation of pressure will be there? For every 10 meters, I said 1 millibar. Okay? For 1 kilometer, what should be the variation in the millibars? 1000 होगा? 100 millibar. ठीक है? 100 millibars variation should be there. But this 100 millibars variation is not true ideally. In the lower atmosphere, there is high variation in the millibars can be seen. But as you go into the higher atmosphere, the variation is not high. Variation is not high. मतलब ज़्यादा हाइट पे कम वेरिएशन देखने के लिए मिलता है. यहाँ पर कम हाइट पे ज़्यादा वेरिएशन. दैट मीन्स एट अ लेस हाइट यू कैन, विथ वेरिएशन इन लिटिल हाइट यू कैन सी लार्ज वेरिएशन ऑफ मिलीबार्स. Right? Now these are some things that you need to know with respect to vertical pressure. Right? Now what is horizontal pressure? Horizontal pressure is literally you will compare this column with an other column. ठीक है? This column of air you will take and compare it with another column of air. You should not mix your thought process or your knowledge. When you learn vertical column, these are specific to vertical column itself. You should not make a khichdi. Whatever you have learned here, you wanted to apply it to the other column. Horizontal. Right? Vertical pressure is different from the horizontal pressure system. For that, let's try to understand the horizontal pressure. Now this horizontal pressure, imagine these are two columns. This is column A and this is column B. ठीक है? Now for this, I say this has high temperature and this has low temperature. Right? And what is the height here? I call this height as 13 kilometers. Right? Tropopause. Now this is the sea level. Got it? So if you have high temperature, what should be the pressure here? Low pressure? What should be the pressure here? Now this high pressure is compared to where? Is compared to what? that you need to have a clarity. I'll call this as point A, I'll call this as point B, I'll call this as point C, and I'll call this as point D. This is low pressure as compared to point D. But when you consider this vertically, where do you have high pressure? When I compare point A and point B, where do you have high pressure? A will always have high pressure. Okay? B always will have low pressure. Right? But when I am comparing point A with point D, I got to learn that A has low pressure and D has high pressure. Samajh gaya? You should always compare the pressure systems like this. Suppose if I am creating a point E, point F, right? G. Now, if I say E has low pressure, now compared to what? Horizontally, it is compared like this. You should not compare like this. Whenever you are comparing vertically, it is always clear that at the surface you have high pressure, more so of sea level 1013 millibars hoga. As you go into the higher heights, it is always the low pressure, right? Now, wind is always moving, or most of the times the wind will move vertically. Okay? Many less times, at few occasionals, you will see the wind moves. Many a times the wind moves horizontally, and in some times the wind moves vertically. Right? So, by this logic, you got to understand that pressure should always be measured at equal heights. In the horizontal, pressure shall be measured Got it? Clear? Now, sometimes I'll be using the word surface winds and sometimes I'll be using the word upper atmosphere. Now, what do you mean by surface winds? Surface winds are those winds where the friction is present. Now, till what height is the friction present? 3 kilometers tak. Now, until 3 kilometers or 4 kilometers height, I'll say that they are surface winds. And anything above 3 to 5 kilometers height, I'll call it as upper atmospheric winds, right? So, that is as compared to sea level. Okay? Surface winds are from the sea level to almost 3 to 4 kilometers of height. These are called surface winds. Human beings, which we experience the wind and all, they are called surface winds. Now, you will learn literally the speed of the surface winds are different from the speed of the upper atmospheric winds. This way lot difference is there. You'll be surprising to know that upper atmosphere mein the winds will be blowing at 250 kilometers per hour, 180 kilometers per hour, 600 kilometers per hour, 500 kilometers per hour also. Okay? Now that means I'm talking about the winds at 13-14 kilometers height. The winds will be blowing at sometimes a speed of 200, 300 kilometers, 500 kilometers. An aeroplane which is moving, it will make that aeroplane move. Maybe an aeroplane which is moving at 600 kilometers per hour, these winds can move that aeroplane at 900 kilometers per hour. Okay? In the Second World War, we have utilized these winds. I'll explain about these winds after some time, right? Now, are you clear with this? Right? Now, the behavior of the wind in these two atmospheric columns, I am going to explain that. Now, how is the behavior of these winds being there? For that, let's again try to understand. This is the surface. This is a high pressure column. Sorry, this is a high temperature. And what kind of pressure do you have here? Low pressure. As compared to where? As compared to same height of the other column. Right? So here you need to understand this little more practically, how the wind behaves. Now, why is that you have so much of high pressure? ऐसा क्या है? If a person who is standing here and a person who is standing here, this person has to experience more weight and this person has to experience less weight. Why is that? शौर्य का कहना है सर टेम्परेचर कम है तो एयर डेंस है, एयर डेंस है तो ग्रेविटी के अट्रैक्शन में आएगा. चलो थोड़ा टेक्निकल भाषा में बताया. I'll make it little more simpler for you. Now let's try to understand that there are 100 units of air which is present in this column and there are 100 units of air which is present in this column. Right? For that, let's try to understand. This is your tropopause. Now at what height is tropopause present? 13 to 18 kilometers. As you all know that if there are 100 units of air in this, just imagine you have 100 units here in this column and 100 units in this column. The distribution of air in this column will be different from that of the high pressure column. See, in the low pressure, there is heat present here, right? The air that is present, much of the air will try to rise up. Okay? Much of this air will try to rise up. And if there are 100 air molecules in this, how are they present? See, 30 molecules might be present here. Okay? Maybe 20 molecules might be present at lower end. But rest of the 80 molecules which are there, they might be present here. It is like this. This is how it is. 20 units of molecules of air or 20 units of the air will be here and 80 units of the air will be present like that. Now, as there is so much of air that is rising, here the air will always try to rise. Right? Now, this rising air, it will be like this. For your understanding, what I'll do is, got it? Air is always trying to rise, but much of the air molecules are present in the upper atmosphere. Now, these air molecules, once they reach to the tropopause, what happens? Beyond tropopause, they cannot get cooled, right? They'll start to diverge outward. Right? Now, this diverged air will start to move towards a comparatively low pressure area, right? So, यहाँ पे clear है? Now, what happens in the high pressure column is that in the high pressure column, much of the air will be at the bottom. It is like this. Look here, the molecules here are it is like this. So that means $70 units must be present here and 30 units are present here. So आप बताओ यहाँ पे कितने units है? 80. So I always told you have to compare your pressures at same height. So you compare the height of these two as compared to 80 and 30. Where do you find low pressure? 30. Low pressure hai. Wind will start to move from high pressure to low pressure. So here the wind will find its way. Chalo mera low pressure kahan par hai? It will start to move in this direction. Once it reaches here, the wind will start to sink. Right? अब यहाँ पे देखो, you have low pressure here. 20 units of air are present here and 70 units of air is present here. So where do you find low pressure? 20 के पास 70 पे ज़्यादा air है. There's so much of air present here and there's low pressure. Now why do you have low pressure here? This low pressure is primarily because there is high temperature, garam कर रहे हो earth को, and this heated part of the earth which is trying to rise that air up, above and above. Now air that while it is rising, it is also cooling the temperature. Air that is rising its height will also get cooled. So broadly, what happens here is, you will see the winds to be descending here. And this descended wind, high pressure में क्या हो रहा है? Is it sinking or rising? Low pressure में क्या हो रहा है? Is it rising or sinking? This is that means sinking column of high pressure, rising column of low pressure, plus look here, what is this? Is it high pressure or low pressure as compared to same height? Clear है सबको? ये तो high pressure हो गया. I'll call this as high pressure. ठीक है? I'll call this as low pressure when I am comparing both the columns at the same height, right? आप बताओ high pressure पे क्या चल रहा है? Is it diverging or is it converging? Just a minute. Oh. See, the air here is moving outward, right? This is called right? Now come to this high pressure column here. Now even at this high pressure column, you will see the air will start to diverge in all the directions. As you have sinking air, now this sinking air will start to diverge in every direction. What happened? So as there is low pressure here, the wind starts to move in this direction. Right? So आप बताओ, here this is low pressure. At the low pressure, you will find the wind to be moving from all the directions. ऐसा नहीं है एक direction है. The wind will be coming from all the directions. This is low pressure. Low pressure in comparison to this particular column. Right? This is low pressure in particular to this comparative column. High pressure. And See, if I take up one more column here, okay, just imagine that I'm going to draw one more column here. What will be the pressure here? Yes. Basically, this low pressure, it is low in comparison to this and in also comparison to this particular column, right? If suppose, if this is also high pressure column, wind will start to come in this direction from all the sides. You see, wind is coming from here also, wind is coming from the other column also. Together they will start to rise. Now this is low pressure system. Do you have converging air or diverging air? Converging air. So at low pressure you have convergence and rising air. At low pressure, and at high pressure you have divergence. Okay? Or else can I say this as high pressure? Sinking air with that of divergence, right? Sinking air plus it is like this. Now, do you see the air that has risen had made a one full circle? मल्टीपल लूप्स चलते हैं. अब एक लूप को हम एक दिस वन फुल लूप विल कॉल इट एज कन्वेक्शनल सेल. ठीक है, विल कॉल इट एज कन्वेक्शनल सेल. गॉट इट? So same is the case, you take this column and see it is high pressure. So you have high pressure here, the wind diverges in this direction and then sinks. That sinking air will start to diverge in all the directions. Got it? Now this is what is also given in your NCERTs, the very, very basic books with a diagram like this. Suppose if this is low pressure system, you will have convergence and rising air this is high pressure system, divergence this is high pressure system, so you will have divergence and sinking air. That's it. And this is also low pressure as compared to this, so you have so that means at every low pressure you have what? Convergence or divergence? Convergence, right? Now all this is linked with what? Temperature. So if there is high pressure here, what is the temperature here? If there is high pressure, so low pressure, so high temperature. High temperature compared to what? Compared to this low temperature. Same way, high pressure, so low temperature, right? Got it? Now this is what it is. Not just MP, it happens across the globe. Okay? Now we'll start to study about the entire system, right? So now what we'll do is we'll go and study the pressure belts of the globe, right? यहाँ तक clear है? High pressure and low pressure concepts. So you know how the wind system works. This in the low pressure system, there is a lot of air present in the upper atmosphere because it is rising, and in the high pressure system, there is a lot of air which is sinking, right? Now, the root cause of this is temperature itself. क्या? पूरा रामायण पढ़ के ये पूछते हो राम कौन है? हाँ, he is asking high temperature कैसे हो गया? अब यही चीज को if this is your earth, जून 21 में हाईएस्ट टेम्परेचर कहां पर होगा? दिस इज ट्रॉपिक ऑफ कैंसर, ठीक है? इफ द हाई टेम्परेचर इज हियर, इफ दिस इज द कॉलम, टेम्परेचर क्या होगा? इफ आई टेक दिस एज अ कॉलम, समझ में आया? हाँ, कभी कभार ना अर्थ को घूम फिरकर इमेजिनेशन में देखना होता है, राइट? सो दिस इज हाउ यू नीड टू इंटरलिंक, राइट? सेम थिंग. नाउ you see at tropic of cancer what kind of temperatures you will have? Low. June 21st the highest temperature is on the tropic of cancer is very high, equator is comparatively low. So if this column of air is there, so aap batao how the distributions will be there. If I am comparing these two, don't you think that the wind will make a circle? Yes, and this is how the wind starts to move across the globe. So for this you need to understand all the pressure belts of the earth, ठीक है? And before that I have to tell you what are the factors which influence the distribution of the wind, and what are the factors which influence the speed of the wind or movement of the wind. ठीक है? Factors that influence the speed of the wind. What are they? Or forces affecting the velocity and direction of the wind. Got it? So we are going to discuss what are the factors that influence the speed, and that is velocity and the direction of the wind. So why should the wind move only in this direction? Why not the wind moving in this direction? It is simply because of the concept of high pressure and low pressure. And you already know that if I am looking forward for the wind here, ठीक है? In order to understand this, we have to draw the wind, the pressure system which is there, by using the convectional cells or else the isobars. ठीक है? Isobars हमें plot करना आना चाहिए. Now what are these isobars and how are these plotted? These things that we have to discuss in little more detail. First, let's try to understand what is an isobar. I'll explain this forces. Before that, I have to tell you what is an isobar. ठीक है? And then we'll discuss about the forces such as gravitational force, number 1. Number 2, pressure gradient force. Is there any other forces which will influence the movement of the wind? That is what is Coriolis force. Centrifugal, centripetal are you talking about? Yes, but they are minimal forces. But more than that, majorly these are the forces. Okay? These 4 forces which we need to know in little more detail. Right? But पहले हम isobars क्या है ये समझेंगे. What are isobars? In simple terms, when I'm going to plot a map using if I'm going to plot a map where I'm going to locate all the points with equal pressures and I'm going to join that line. Yesterday I told you that if suppose this is my India or across the globe, see, I'll point few places. Imagine all these points which I have put on the board, they have equal pressure by the name 1013 millibars. Okay? Or else 101010 millibar. So if I am going to join these points, this is called an isobar. Okay? Likewise, always the pressure gradient or the wind speed is decided by drawing this isobars by the Indian Meteorological Department. Right? So कभी कभार ये जो isobars है ना, they will be present like this. Can you imagine this, what I have drawn? They are all isobars. समझ गया ना? Pressure difference. So these are your isobars. If this is your north, this is south, east and west. So आप बताओ, in which direction do you find the isobars to be closer? In which direction the isobars are closer? North and west के बीच में, this is the direction in which the isobars are closely present, and here the distance between isobars is wider. So some time back UPSC asked a question, when the isobars are closely located, the wind speeds are higher. This is statement 1. This is statement 2. When isobars are distantly located, the wind speeds is less. ठीक है? Are these statements right? If isobars are closely located, the wind speed is higher. When isobars are located distantly, the wind speed is less. Is this statement right or wrong? Right, Shaurya says. कौन सा लॉजिक से बताया आपने ये राइट है? Yes, his logic is right. Very good. See, if the distance between two isobars is closer and the gap between them is higher, देखो मैं gap अगर कहाँ, or else difference, when I say the difference, I mean to say, if suppose this is 1010 millibar and the next isobar line can be 101002, ठीक है, what is the difference? This isobar is 1010 and the next line, this one, is 1002. What is the difference? Yes, 8 millibars. That is the difference. Now, between these two, the difference is same. But ये मान के चलो, this is 100 kilometers distance, and the difference between them, the distance between them is only 10 kilometers. Here the wind will be moving faster, and here the wind will be moving slower. The closer the isobars, and the higher the difference between millibars, the wind speeds will be higher. You can write, isobars are places where equal pressure points are joined. Isobars are places or lines where equal pressure points are joined. Right? Okay? So, if the difference between two isobars is higher and the distance between them is lower, if the difference between two isobars is lower and the distance between them is, can you please repeat? If the difference between two isobars is higher and the distance between the two isobars is lower, okay, then the wind speed will be higher. If the difference between two isobars is higher and the distance between two isobars is lower, then the wind speeds will be higher. Difference in millibars, ठीक हो, ये लिखो, it will clear your confusion. Difference in millibars, here the word difference is millibars, distance is in kilometers. ठीक है, distance means kilometers, difference is in millibars. Right? So let me make this little more clear for you. See here. For example, I am taking points. This is point A, this is point B, point C, point D, various points. If I say the lines that I am going to join is 1012 millibar, ठीक है? So see here, I am joining all these points. That means this particular line which I am drawing, if I am going to point any place, what is the pressure here? Same, sub same hai. Right? The next line that I have taken is, these are the points. Right? Now what is the pressure here? 1010 millibar. Right? I am going to join these places. Right? आप देखो, what is the distance between them? Suppose this is northern part of India. The distance between these two isobars, is it lower or higher as compared to southern isobars? Here, less. So for little more understanding, what I'll do is I'll draw these isobars closely here. Right? So this is 1012, 1010. I'll call this as Got it? अब आप बताओ, the distance between each of these isobars, is it lower or higher as compared to southern regions? Distance is क्या है? Suppose if I take two places, this is point A and this is my point B, ठीक है? And this is my point C and this is my point D. Right? From A to B, imagine the distance is 100 kilometers. Right? From C to D, the distance is near about 600 kilometers. Right? So, here look very carefully. 100 kilometers pe, what is the difference if the last isobar that I have drawn here is 990 millibars? ठीक है? This is 990 millibar isobar I have drawn. So from 1012 to 990, this is 1012, this is 990. This is 22 millibars is the difference. From C to D, what is the difference? D is also 990 millibars. ठीक है? And C is also what? Same 1012. So, what do you see? How much MB? 22 millibars. Ab looking, repeat, please try to read the sentence which I have dictated and look here. You tell me if this is north, this is south, this is east, and this is west. So in which direction you will see the winds coming very, very fast? अब समझ में आया? Basically, if the difference between millibars is higher and the distance between them is lower, then the wind speed will be higher. The wind speed will be very, very high. It is like this. The wind speeds come with great speeds, but here the wind speed will be lower. ठीक है? यहाँ पे बहुत ही तेज हवा, very, very fast air will come into picture. Here slow wind will be there. Right? जितना ही ज़्यादा pressure gradient है, pressure gradient is the difference between high pressure and low pressure. That is called, the difference is called as pressure gradient. If higher is the pressure gradient and lower is the distance, the wind speed is higher. Got it? Right? Now this wind which is moving, the speed is primarily dependent upon one, on the pressure gradient. ठीक है? समझ गया ना? One is pressure gradient. I hope everyone is able to understand if I am using the word pressure gradient. Right? Pressure gradient means the difference between 2 millibars is very high. If the difference between 2 millibars is very high, what does that indicate? It indicates that the temperature difference is extremely high there. Right? Now coming back to what are the forces that are responsible, or what are the forces that impact the movement of the wind. First one is pressure gradient force. You got to understand. Now second one is frictional force. Frictional force, I already told you, if the wind is near to the surface of the earth, then the frictional force is higher. So the wind which is moving near to the surface experiences frictional force. That's the reason why your wind will be moving slower near to the surface. But as soon as it reaches to the upper atmosphere, near about 8, 9, 7 kilometers higher, the wind speed will be faster. ठीक है? Because there is absence of friction. And upper atmospheric winds, they are also called as thermal winds. ठीक है? Upper atmospheric winds, they are also called as thermal winds. I'll explain what are these thermal winds in the further class, but now consider it as a fact. Upper atmospheric winds, any wind which is more than 6 kilometers higher or 5 kilometers and beyond higher, they are also thermal winds. Sometimes these thermal winds can also be present from 1000 to 1500 meters also. Now, what are these thermal winds? How are they different from the normal winds? See, normal winds are the winds which are dominantly driven by pressure gradient force. Normal winds which are present at the surface are dominantly driven by pressure gradient force. Means there is good difference in the pressure, so that's the reason why the wind is able to move faster. Low pressure, high pressure. But as soon as you go into the upper atmosphere, the properties change. Okay? In fact, there temperature is the driving force. Okay? Temperature is the driving force. मैंने क्या कहा था? I told you, factors that affects the velocity and direction of the wind, that can be influenced by gravitational force. ठीक है? That's the reason why wind is not moving up if gravity is not there, right? If gravity is not there, wind should have moved up, but gravity is there. That's the reason why wind is staying at the surface. Else you, me, everyone will be floating in the space. So gravitational. Pressure gradient force, you got to understand this now. High pressure and low pressure difference. Other one is thermal gradient. Thermal gradient is also the temperature gradient which is present in the upper atmosphere. This we'll talk little later. This is called higher geography that I'll deal in the jet streams. That is nothing but your jet streams. Right? Now coming to the concept of frictional force. Frictional force is a force, I told you it is present at the lower atmosphere very high and upper atmosphere low. Now coming to the concept of Coriolis force. Coriolis force is also called as deflective force. ठीक है? Or else it is an apparent deflective force. It is an apparent deflective force. See, to understand this Coriolis force, first you need to have little imagination. Right? Now whatever I'm going to tell you, you should imagine this in 3-dimensional, then only you will be able to understand in little easier manner. Else घर जाके आप कोई भी round सा object which can rotate, you can hold it in your hand and then try to understand that. Right? So imagine that this is your earth. Coriolis force many students flunk here. Basically, lack of imagination is the one that will not give you the clarity. But even if you can't imagine how Coriolis force works and all, never ever UPSC has entered into this domain, explain Coriolis force. ठीक है? 5 marks, 10 marks. No. All you need to know is Coriolis force is towards right in the northern hemisphere and towards left in the southern hemisphere. Even if you know this, काम चलता है आपका examination point of view से. Now if someone is going for geography optional, then these things, what is the role of the Coriolis force in the movement of the wind? This is what they can ask. So for you to understand this Coriolis, first you need to understand the properties of the earth. ठीक है? Earth is a geoid. Now what do you mean by geoid? Earth is bulged at equator and almost flat at poles. Suppose I put a point here and I put a point here. Now this point to go around the earth, how much time it takes? 24 hours. क्योंकि ये पूरा एक rotate करना है. Same wise, if this point, it has to go around the earth and come back to its position, how much time it takes? 24 hours. But who is traveling more distance? equator. So can I say that people who are living at the equator, they are moving faster? ठीक है? Or else, can I say that Earth moves faster at the equator and slower at the polar region? हाँ, देखो, a person who is standing here will take 24 hours to make one full rotation. Same wise, a person who is standing here will take 24 hours to make one full rotation. Naturally, if you are standing on the earth. But the distance covered by this person is only this much. But this person has to cover a larger distance. Suppose if I open up this circle, if this is the distance, this will be the distance which shall be covered. Yes? If I am opening up this circle and making a thread, so this is the distance which is covered by the polar regions of the earth or near to the polar regions of the earth, and this is the distance which is covered by the equator. That means because of this, there is the rotational speed difference will create some kind of deflection. ठीक है? How? Let me explain that. अब तो ये समझ में आया ना? Earth rotates at different speeds at equator and at poles it is different. Right? Yes? Yes, talk. Yes, yes, absolutely. Yes, absolutely. So, this is how the rotational speeds of the earth are. At the equator, it moves at 1650 kilometers per hour. At little more 23.5 degrees north, 1550 kilometers per hour. And then 1275, and at the poles it is 0 kilometers per hour. Because poles pe, it is, you're just standing. Maybe today at 8 a.m. you will be standing this side. You'll just make a rotation like this. Right? If you're standing at the North Pole. Literally you will be standing like that. But if you are standing here, you will make a circle of 1550 kilometers per hour. Now see, because of this, there is a deflection that shall be there. Now that deflection, to understand this, what we have to do is, what I'll do, if I am looking at the earth from the North Pole, this is the earth, and if I am standing here, or else I am watching from the space, right? Isn't it looking like a disc? Merry-go-round खेला है बचपन में? Huh? Imagine if I am rotating this earth, it goes round and round and round. हाँ, जब आप, if you are standing near this place, you will experience less force. But if you are standing here, merry-go-round को हिंदी में क्या कहते हैं? जैसे गोल गोल घूमता है ना बचपन में. Just a minute. This one. What do you call it in Hindi? लेकिन बचपन में तो you have seen, or at least if many of you have played. Now, to make this little more understanding, for the understanding little more easier for you, let's imagine I am going to take you to the South Pole. ठीक है? Instead of North Pole, I'll take you to the South Pole. You're standing here, or you're watching this from here. Now, is the earth rotating in clockwise or anti-clockwise? Earth rotates like this. ठीक है? West to east. But this earth, I'm turning it like this. Now, what is the rotational direction? Is it rotating like this or like this? like this or like this. ठीक है? If I am doing now, it is like this only, no? Clockwise हो गया ना? Because here your perspective is from South Pole. Got it? But in Earth always rotates in anti-clockwise. If you are looking from North Pole, if you are looking from South Pole, it is clockwise. So imagine I am going to convert this into a merry-go-round. ठीक है? Merry-go-round पता है ना? The one which I have shown you. So see here. This is a merry-go-round which is moving in the clockwise. If suppose, look at this ball, this person wants to pass to the straight opposite guy. Always the deflection is towards left or right. So it is towards left. Right? Instead of this ball, what I'll do is, I'll draw the winds. ठीक है? Instead of this ball, I'll draw the winds. The winds, imagine same thing. Our Earth is rotating from the South Pole. If I'm looking forward, it is rotating in clockwise direction. So this winds, when they are trying to move towards the center, ठीक है? Or else, if this person wants to move in this direction, here the deflection is towards left, right. So imagine this wind wants to come here. This wind wants to come here. What is the deflectional direction? Left or right? Left. So ultimately, the ball will be reaching, or the wind will be moving in this direction. Got it? समझ गया? So same thing, if I draw it like this, this is the South Pole, the deflection will be like this. If you wanted to move in this direction, the deflection is towards left. If you want to move actually in this direction, the deflection is towards left. In this manner, the deflection is towards left again. Finally, if you are moving in this direction again, the deflection is towards left. This is how the movement is. Any wind which is moving in the southern hemisphere, it will always deflect towards its left. Right? Same way, if you look the merry-go-round from the northern hemisphere, the deflection will be towards its right. Okay? The deflection will be towards its right. So, in simple terms, what I want you to remember is the Coriolis force deflection in the northern hemisphere, it is towards its right. In the southern hemisphere, it is towards its left. It is like this. So the deflection is towards right. Ultimately, the wind will move in this direction. Right? If suppose it is moving in this direction, it will deflect towards its right. It is moving in this direction, it will deflect towards its right. In the northern hemisphere, deflection is towards right. Southern hemisphere, towards left. I know this is little difficult for you to imagine, but trust me, UPSC since its last 55 years never ever asked to explain Coriolis force. Okay? They might ask you what are the impacts of the Coriolis force. Same way, a bird that is moving in this direction, it gets deflected. An aeroplane will get deflected. A wind gets deflected. A butterfly moving for longer distances, it will get deflected. Simply because the earth which is there at the equator, it is moving at faster rate, and at the polar region it is moving at a slower rate. If you are moving from one latitude to another latitude, literally you are actually moving away from that same speed. You are moving from into the variation speed. So that is the primary reason why you have the Coriolis force. See, Shaurya's question is that, sir, how do we reach the objective or the target? You will never reach the target. if you are moving in a straight line. Even aeroplanes also, what do is they always deflect. They understand the Coriolis force, because today we know what is the speed of the earth, what is the speed of the aeroplane, right? How many latitudes it is going to get deflected, how many latitudes it is going to get deflected. So based on that, your aeroplanes will decide, if I am moving in a straight line, I will not reach the target. I would rather change the direction and move accordingly. Okay? Got it? So even the wind, the oceanic water, all will experience this force. Okay? This is what is Coriolis force. In simple terms, ye yaad rakhna. In the northern hemisphere, anything that is moving in the atmosphere, in the air or in the water, it will deflect towards its right. Ocean currents also move towards its right. Right? Ocean currents, birds, aeroplanes, wind, even butterflies of large migrants, all will deflect towards their right. Yes, yes. That is why. जिस जगह पे आप खड़े हो वो भी मूव हो रहा है, जिस जगह पे आप जाना चाहते हो वो भी मूव हो रहा है, और you started to take a flight to reach that destination. If you are moving in a straight line, you will not reach that destination. ठीक है? That deflection which is there, that is called as Coriolis force. Right? This is an apparent force. Apparent force. ठीक है? Apparent force. This is sun which is there. The movement of the sun, we called it as an apparent movement, right? So likewise, this is an apparent force. Now this Coriolis force is also influencing the movement of the, or movement or direction of the wind, right? As well as speed of the wind also. ठीक है? A wind which is moving in a straight line will move faster, but a wind which is taking a curve, curvated, it will move in a slower way. Right? Clear? If you want to take a photograph, quickly take it and okay. Sir, how can pressure be same when their heights are different? See, Munendra asked a question, sir, how can pressures be same when their heights are different? At different heights, you can have different pressures. But all that pressure same and difference is completely dependent on temperature. Yes. Temperature plays a vital role. It is not that at same heights you will find same pressures. It can be varying pressures. Right? Okay, now what we'll do is we'll move one step ahead. Gravitational force we are done with, pressure gradient force, Coriolis force and frictional force. Clear with this? Now every wind which is moving will experience these forces. Sometimes alone gravity can overpower all of this. ठीक है? Sometimes only Coriolis force can overpower. Sometimes frictional force can overpower. But in one or the other way, you will always see that either gravitational force or pressure gradient force, they'll have their impact. But sometimes one of these forces will overpower the other forces, and then they will take the wind in one direction. ठीक है? You should not always think that, sir, यहाँ पे Coriolis force ही लगना है. नहीं. कभी कभार Coriolis force को overpower करने के लिए ये force हो सकता है. ठीक है? Sometimes you might ask me, sir, why is the wind moving up? Gravity तो है. Sometimes pressure gradient can come into picture. It will outpower, it will overthrow gravitational force, and then the wind will start to move up. For example, you take a low pressure system. This is a low pressure system. In the low pressure system, high temperatures are there. How is the wind moving in the low pressure system? यहाँ gravity काम नहीं कर रहा है क्या? Gravity is also there here, but pressure gradient is more. Right? So you should not think that absolutely हमेशा the wind should be moving only in this directions. No. That is not true. You should be open for all the possibilities. But primarily, these are the four major forces that will be impacting the direction and the velocity of the wind. Now, using this knowledge, we will try to understand the pressure belts of the world. Now I am going to integrate all the content. समझ में आ रहा है ना सबको? Clear with that? Now pressure belts of the world. Pressure belts are nothing but if suppose my earth which is there on a particular latitude, if you are finding similar kind of pressure, you will call it as pressure belt. ठीक है? If you find similar kind of pressure on this entire region, you will call this as a belt. Sometimes belt matlab literally earth will have a belt. Sometimes there can be pockets of pressure on the same latitude. That means this area will have uniform pressure, this area will have uniform pressure, or sometimes this entire earth region can have uniform pressure. Yes, there can be gaps also. That gaps, yes, variation in temperature ki karan, because of the variation in the temperature, you will find these gaps. Why and all I'll explain further. But learn this as a fact now. There can be pockets. Now let's try to understand this. See, across the globe, there can be two different types of pressure belts. One, thermally induced pressure belt. Second one is dynamically induced pressure belts. Right? Clear? So, thermally induced and dynamically induced. Now, what do you mean by thermally induced? In simple terms, temperature is the dominant factor in temperature is the dominant factor in making the pressure belt, right? Now, dynamically induced in the sense, other than temperature, there can be other factors. Simple. It can be pressure, it can be temperature, it can be various other factors. Local factors bhi ho sakta hai, dynamic factors, any factor you can think of, right? So, overall, on the earth, if you look into the pressure belts that are thermally formed are 1 at the equator. ठीक है? Now at the equator you will call as equatorial low pressure belt. Right? All throughout the year, here you will find good amount of sunlight, irrespective of the seasons. I told you average temperature is near about 35 odd degrees Celsius. So 35 to 40. And that is the reason why you have high temperature all throughout the year if you take out average. So that's the reason why this is called as low pressure belt. Okay? Ideally, whatever we are reading, this is all ideal. Right? So, you go to the tropics. Okay? This is your tropics. This is at the tropics. Comparatively, do you have high temperature or low temperature all throughout the year? Average अगर लिया गया. As compared to equator, do you have high temperature or low temperature? Low temperature. When there is low temperature, what kind of pressure belts do you? This is called subtropical high pressure belt. Right? Likewise, you will also have a subtropical high pressure belt in the southern hemisphere also. Yes. Now, I have used the word doldrum in the beginning. So this equatorial low pressure belt region is nothing but doldrum region. Okay? 0 to 5 degrees north. Now, this is present between 0 to 5 or 0 to 10 degrees north and south. For this, I'll dictate notes. It is not there in your NCRTs or any other book. So, try to understand this. Now, likewise, when I go to polar region, this is poles, right? Right? Now, polar region, is my temperatures cold or warm? Cold. As compared to the rest of the world, polar regions all throughout there, it is cold. So, when you have cold temperature, what do you have there? High pressure. So, you call this as polar high pressure belt. Now, it is present near to the polar region, like this. Same case in the southern hemisphere also, you will find. Clear? So, come to 66 degrees north and south. 66 degrees. So, this subtropical high pressure belt is present between 20 to 30 degrees north and south. Between 20 to 30 degrees north and south. But now I am asking to come to 66.5 degrees north and south. As compared to polar regions, do you have high pressure or low pressure? Low pressure. So it is subpolar low pressure belt. I know many of you will now have doubts. I'll clear that also. Got it? So this is how the earth has 7 pressure belts. Count. How many are there? 1, 2, 3, 4, 5, 6, 7. This is north subpolar. This is north polar. This is subtropical, subtropical high pressure belt in the northern hemisphere, equatorial low pressure belt, subtropical high pressure belt. Then you have subpolar low pressure belt and polar high pressure belt in the southern hemisphere. Right? अब इनमें से कुछ ऐसे प्रेशर बेल्ट्स है विच आर थर्मली इंड्यूस्ड एंड सम प्रेशर बेल्ट्स आर डायनेमिकली इंड्यूस्ड. ठीक है, थर्मली इंड्यूस्ड मींस temperature is the dominant factor. So here, this particular equator, it is thermally induced pressure belt, right? And see, polar region, it is also thermal plus dynamic reasons. Right? Next, subtropical and subpolar high pressure this subtropical high and subpolar low, both are actually, these pressure belts are forced to be formed. They are forced. Literally, they are forced. Had if an option is given, they don't like to make a pressure belt, but they are forced. Right? So, आप बताओ, high pressure belt पे क्या होगा? Is it converging or divergence? High pressure belt is divergence. Do you find sinking or rising? High pressure belts में sinking होता है, divergence होता है. Same concepts shall be applicable here. Right? First, suppose the diagram which you are seeing now, you have to imagine this in 3 dimension. ठीक है? You have to imagine this in 3 dimensions. Now, how do you imagine this in 3 dimensions? Suppose if there is equatorial low pressure belt. Yes, properly ले लो, zoom करके ले लो, कोई issue नहीं है. Okay? So, here, if suppose the air that is rising, you have to imagine that the air is rising on the earth. ठीक है? So, my diagram here, I cannot draw the air. Within the air, I cannot draw the air. So, that's why what I'll do is, here, I'll start to rise the air. ठीक है? This is equatorial low pressure belt. In the low pressure, the temperatures are very high all throughout the year. Ideally, we are studying this in an ideal manner. So the winds will start to rise here. So in literal terms, how you have to imagine? You have to imagine that the winds are rising from all the direction, not just here. As I cannot draw these kind of lines in the air, so that's why I am drawing it on the sides. Same way, jitne bhi books mein authors hai, they have also drawn it like that. So because of that, many students face difficulty in understanding this concept. Once the air that is risen, what happens to this air? This is low pressure system. Air will start to diverge, right? So this starts to diverge on either sides. Right? Now when this is diverging, you know that this is subtropical high pressure belt. What happens to the high pressure belt? It starts to sink. Right? Here, the air started to sink here. Now where is it sinking? It is sinking in the subtropical high pressure belt. I hope you are able to understand this. Air rising, diverging, and then trying to sink. Yes. मैंने जो convectional cell बनाया था, low pressure में sink कर रहा है, and it is diverging. This is your equator, right? This is your subtropical high pressure belts on either sides. It is making a cell like this. So this kind of cell, you will call it as convectional cell, and this convectional cell has a name to it. I'll explain that after 5 to 10 minutes, but be patient. Try to understand this. Now see here, this wind which is there, it started to, once it starts to descend, I told you, in the low pressure, in the high pressure, the wind starts to sink and diverge, right? So here, sinking and divergence starting to take place. Clear? I hope यहाँ तक clear है? Okay. Likewise, you will see, look at this particular cell. Come to polar region. Come to subpolar region. In the polar regions, do you find sinking air or rising air? Here the temperatures are very, very cold. So when there is cold temperatures, you have high pressure system. In the high pressure system, you always see the wind to be sinking and diverging. So here the air sinks. The air sinks and the air will start to move in every other direction. ठीक है? Likewise, it starts to sink and then ये subpolar low pressure belt है. Here it will start to rise. Got? Low pressure belts, what do you see? This is a low pressure belt. Air that is risen, it will start to diverge, right? Same way, the air will diverge and the same air will come and sink. It has made a cell. Because this is thermally and dynamically induced. Thermally induced belts are more stronger and dynamically induced cells are forcefully formed because of the thermally belts. So this is one convectional cell which is formed and there is another convectional cell this is formed. Now you see these two dynamically induced belts, they are forcefully formed, right? Because they are very, very strong belts. And forcefully, what do you see is that the cell is completed here. It is like this. Now you see, at the high pressure belt, the wind starts to sink, and this wind, as soon as it's reached to the subpolar low pressure belt, it will start to rise. Same way, in the southern hemisphere also, the wind which has come here, it will start to rise here. Yes, you have cells, almost 6 cells. So likewise, you will see that once the air that is risen there, it will start to diverge and it will sink. Right? Now there are multiple cells which are present on the surface of this earth. Now these multiple cells are actually identified and found by scientists. Now in your NCERT, if you open your books, it is written as there are names that are given to these cells. That is nothing but this is your Hadley cell. This is also Hadley cell, because Hadley is the one who have first given this concept. After completing, then you take Ferrel cell. This is also Ferrel cell. And this is polar cell. Right? Clear? Got it? Now, looking at this diagram, can you tell me where are upper atmospheric winds and where are surface winds? Upper atmospheric winds are in which color and surface winds are in which color? So, yes. See here, this is your upper atmospheric wind. This is your upper atmospheric, upper. Now these blue are your lower atmospheric winds. And I told you, what are the forces that are present on the moving wind, which influence the direction and velocity of the wind? One, pressure gradient, Coriolis force, gravity, and frictional force. So these winds are not experiencing friction, one which are present in the upper atmosphere. But friction is experienced by the lower atmospheric winds. Plus, they also experience Coriolis force. Both the winds, all the winds experience Coriolis force. Now let's try to understand the winds that are moving from subtropical high pressure belt to equatorial low pressure belt. Okay? See here. First, I'll take one particular column and let's try to apply this. In which direction are they moving? Winds are moving from subtropical high pressure belt to equator. This is how the wind is moving, right? यही तो है. Any confusion? Clear? In other words, isn't it, if this is your equator, this is Tropic of Cancer, what I have done? This is red color winds, this is blue color winds I have told, these are your surface winds. Now the surface winds will be moving in this direction, right? Am I correct? Yes. Now there is a Coriolis force that is present. What is the direction of the Coriolis force in the northern hemisphere? That means net, this is how the winds are moving. Am I correct? So this is how the winds are moving. Now same thing, I am going to draw it here. Look here, the wind shall be moving by deflection. This is the direction in which they are deflecting. The winds seem to be moving from east to west or west to east. This is east, this is west, always. The winds seemingly moving from east to west, so that's the reason why they are called as easterlies. Okay, then what are easterlies? Easterlies are the surface winds which are present in the Hadley cell. Okay? Likewise, apply the same concept in the southern hemisphere Hadley cell between 20 degrees north and 20 degrees 0 degrees equator. So are you sure westerlies होगा ये? Coriolis force in the southern hemisphere is left. This wind will deflect towards like this. Got it? So this wind will deflect like this. How are they seeming to be? East to west or west to east? East to west. ठीक है? They are actually they deflect towards the east. So in simple terms, these are easterlies, east to west they seeming to be. And they are present across the globe. The same winds are present all throughout the year. Now, yes, spiral, as a belt they are present. Now they are easterlies. Okay? Likewise, draw for this. These are surface winds. Okay? Look at this surface winds. What is the deflection? Towards right. Are they moving from west to east or east to west? Coriolis force in the northern hemisphere is towards right, so this is called as westerlies. Now where are westerlies present? The Ferrel cell surface winds. Southern hemisphere also the same. Try to apply the same here. Coriolis force is towards which direction? Left, right? This is how the winds move. So what are these? This is east, this is west. So west to east, westerlies. Likewise, polar. So polar region, these are polar easterlies. Right? Same Coriolis force you apply. If the wind is moving in this direction, what is the Coriolis force? Towards right? ये हो गया polar easterlies. I think, did I do this wrong? Yes, it should be. Coriolis force मैंने उल्टा लगाया. Left, right. These are polar easterlies. So likewise, our earth will be having these kind of winds. ठीक है. In a nutshell, this is your atmospheric circulation. So in the polar region, you have easterlies. In the subtropical regions, you have westerlies. And then you have easterlies again in the subtropical regions. Dominantly, do you have westerlies or easterlies on the surface of the earth? Now, these winds are surface winds. They are not upper atmospheric winds. I am not talking about upper atmosphere. Upper atmosphere बहुत ही notorious winds है. ठीक है? These surface winds which are there, you need to know about these surface winds because that is how they are shaping our life. Only in aeroplanes and all we go to the upper atmospheres, but broadly when you look into, you need to know this. I'll try to show you the upper atmospheric winds here. Just a minute. See, these are surface winds. Look how the winds are moving on the surface. But I'll take you to near about 13 kilometers height, 11, 12 kilometers height. How are the winds moving? And look at the speeds here. What is the speed of the wind? In the upper atmosphere, the speeds of the winds are way, way higher. So these are upper atmospheric winds. We'll learn about them little later. Okay? Friction is one of the reasons. Now look at the speed of the winds there. 266. If suppose an aeroplane which is moving, it will also move at the same height, right? So in the same direction if it is moving, the aeroplane will move faster. So aeroplanes will take into consideration all of these things. Height dekho. We are looking into the heights of near about, yes, near about good height we are maintaining. यहाँ पे प्रेशर देखो 200 PA 11.7 किलोमीटर्स की हाइट पर है. ठीक है, aeroplanes will move in this range itself. So basically wherever this is, aeroplane has to descend, no? It had to fight these winds and then descend. It's not that easy. They know the geography then lot better than you. Right? So here these are some things that you are supposed to know on a practical terms, but we'll stop here for today and tomorrow we'll continue with this. घर जाके पढ़ के आना NCERT में लिखा है. So all of these things, please try to understand the diagram in little more detail. Only then you will be able to understand the climate, the rest of the climate. So once we are done with that, we'll move a little more faster. Right? I've been very slow today. ताकि I wanted to give that conceptual clarity. So practically मैं समझाता हूँ how these things are understood and all. So we'll stop here and tomorrow we'll continue. Thank you online. We'll meet tomorrow. Purav, okay Purav, done. Is the class boring?